February 1943, Tunisia. In the dusty field of Sidi Bouzid, a German major observed the newly captured American tank and uttered a comment loaded with irony. For him, that too simple machine could never teach Reich engineering anything. It was the common belief among German officers and designers, the belief that they alone mastered the true science of armor. What he didn't know, as he walked around the white star still visible in the hull, was that that trust was about to collapse quietly and irreversibly, because that seemingly banal Sherman brought with him a truth that no German engineer had predicted. America did not build tanks to impress. He built tanks to work. Riding 350 kilometers in hostile terrain without a single failure, he exposed a deep fissure at the heart of German mechanical doctrine, a fissure that would soon turn into an abyss. This story presents the trajectory of this single vehicle, taken intact to Berlin, disassembled piece by piece, tested to the limits, and capable of provoking the most uncomfortable conclusion recorded in the Reich's technical reports. They had never achieved that reliability, and that's how an ordinary tank revealed the true industrial superiority of warfare. But before we dive into the confidential reports, there's one statistic that defines this story better than any metaphor. In 1943, as the new German Panther tanks broke down after less than 100 kilometers of field operation, a single American Sherman, captured intact in Tunisia, traveled more than 2,000 kilometers under rigorous mechanical tests, requiring no critical maintenance. Every gear, every axle, every inch of the vehicle was inspected by the best engineers in the Reich, and they all came to the same uncomfortable conclusion. They had never designed anything with this level of durability. This is the story of the day when reliability won over prestige, and when data overturned doctrine. If you value the story as it really happened, with accuracy, sources, and respect for engineering, leave your like and subscribe to the channel. This helps us to continue to bring to light the forgotten facts that changed the course of the war. On February 15, 1943, during the Afrika Korps offensive at Sidi Bouzid, an American armored column was surprised by a coordinated attack by the forces of the 501st Panzer Battalion. Among the wreckage and abandoned positions, a Sherman Model M4A1 tank was found largely intact, its white star still visible beneath the thin layer of dust and soot. There was no mark of sabotage, no signs of mechanical malfunction. To the Germans, this was a tactical gift, another piece of propaganda to be displayed as proof of American technical inferiority. The local command ordered an immediate assessment, and confidently, the German crew of a reconnaissance unit set the tank in motion, beginning a crossing of more than 350 kilometers to the port of Sfax. For 4.5 days, the Sherman crossed terrain that demanded the most of any armored vehicle: dunes, patches of loose stone, dry ravines, and temperature variations that defied engines and suspensions. What was supposed to be a simple transport revealed something disturbing. The tank would not stop. There was no overheating, traction failure, hydraulic leakage, shaft breakage, or any sign of structural fatigue. A Panzerwaffe lieutenant, skeptical at first, began recording details of engine behavior and fuel consumption. By the end of the trip, the informal comments among the officers had gone from mockery to unease. That was not normal. It was too functional, and for a doctrine that had been built around the idea that its armor was superior by definition, seeing an enemy machine cross the desert without any kind of technical intervention was disconcerting. German mechanical doctrine was based on a principle of excellence, maximum performance, even if it required maximum complexity. The machine was supposed to be a masterpiece, even if it made it fragile. In the German view, simplicity was synonymous with inferiority, and the Sherman seemed too simple. But there, under the North African sun, he had just contradicted everything that German engineering believed about reliability. There were no custom parts, handmade gears, or exotic solutions. It was a mass-production tank, and that's what made it dangerous. During the 4 days of crossing, the only interventions made on the Sherman were supply. No tools were needed. No inspection was requested. The Continental R975 radial engine kept the temperature stable even on steep hill stretches in extreme heat. The gearbox showed no noise or abnormal resistance. The tracks and suspension behaved as if they had left the factory the day before. And it was at this point that the restlessness became an alarm. The commander of the operation requested that the tank be sent intact for technical tests at the Kummersdorf field, on the outskirts of Berlin. The goal was clear: to understand what exactly was inside that machine that made it so stable, because something was wrong, and it wasn't with the tank, it was with expectations. The Wehrmacht knew that the United States had a massive industrial park, but the illusion that mass production was necessarily accompanied by low quality still prevailed among German engineers. It was a reasoning rooted in centuries of artisanal tradition. However, this single captured specimen began to contradict the premise. The engineers didn't know it yet, but they were about to face the reality of a country that produced an average of 4,000 tanks per month, compared to Germany's 300 to 400 in the same period, a difference of 10 to 1. This type of comparison until then was disregarded as irrelevant. After all, it was believed that German tanks were worth 3. But when a single Sherman rode more than 3 Panthers together, the equation stopped working. If this number surprises you, write in the comments, logistics wins, because that's what Germany would learn the hard way. The Sherman's voyage to the port of Sfax, rather than just a logistical trip, turned into a practical demonstration of what the Germans had not anticipated. American industrial superiority was not just quantitative, it was qualitative, and the fact that this quality arose precisely from simplicity was, for the Reich engineers, almost a technical heresy. When the tank was shipped to Europe, it was given a new designation and a new purpose. It was no longer a trophy. It was a mechanical mystery that needed to be understood before it became a strategic threat. The vehicle was provisionally named Zugfahrts 259 by the Germans and was to be received by teams from the Heereswaffenamt, the Army Armament Office, under express orders to keep each system intact for analysis. The tank was carefully documented, sealed, and sent on a journey inverse to that of the troops who had operated it in Africa. A journey not only geographical but ideological, from contempt to restlessness, from arrogance to the need to learn. German engineering, considered the most advanced at the time, was about to face an adversary it had never respected, American automotive engineering. And as War Daddy 2, as the Americans had named it, crossed the Mediterranean toward Europe, it carried more than steel. He carried with him the evidence that the enemy had understood something that the Reich had ignored for too long. And in Kummersdorf, the revelation would be meticulous, humbling, and undeniable. Transported under constant surveillance, the captured American tank crossed the Mediterranean with direct orders from the Heereswaffenamt. Nothing was to be altered, dismantled, or tampered with until arrival at Kummersdorf. This was no longer an enemy vehicle. It was a technical device under examination. Formally designated as Zugfahrts 259 and equipped with a WH-058941 plate, the armored vehicle was received on the outskirts of Berlin with the same care reserved for secret prototypes of the Reich itself. The Kummersdorf Proving Ground, located 25 kilometers from the capital, was the nerve center of German armaments evaluation. There, engineers and technicians subjected both their own designs and the captured material to the strictest technical scrutiny. What set that Sherman apart from other tanks previously analyzed was the unstated expectation. From the earliest reports from North Africa, something about that vehicle had puzzled officials, and when Speer's order came in that it be tested in full condition, the message was clear. There was more to it than looks. The psychological impact of the operation cannot be underestimated. Taking an enemy tank into the heart of Nazi Germany for a full battery of tests meant admitting a doubt. For the first time, the American machine was no longer seen only as a target, but as a possible engineering threat. In the Kummersdorf yard, technicians gathered for the initial inspection. Every detail was photographed, measured, recorded. The improvised painting still showed the original inscription, War Daddy 2. The designation G Company, 1st Armored Regiment, 1st Armored Division was still visible on the left side of the hull. A curiosity, perhaps. But what really attracted attention were the construction patterns that were beginning to reveal themselves. The VVSS suspension with coil springs operated with unusual fluidity. The hull welding, although apparently rudimentary to German eyes, showed uniformity and strength. And then came the transmission measurements. Unlike German systems, which relied on straight-cut gears and required minimum tolerances, the Sherman used herringbone-type helical gears, more complex in theory, but widely used in the U.S. automotive industry. For the German engineers, this was a silent affront. How could a country that prioritized mass production be able to manufacture components of this precision at scale? The answer was beginning to bother. What the Germans called raw serial production was in fact a mature and technologically stable industrial chain. The Sherman's trip to Berlin, more than a physical transport, represented a symbolic crossing. The American machine had come out of a battle in Africa and was now in the heart of the Reich, provoking silent questioning in every technician who examined it, because the more they measured, the less they could despise. The internal systems were standardized. The electrical cables followed a color code. The connectors had an easy and quick fit. The tower rotated smoothly. The radio worked. Everything worked. And nothing was exceptional. None of the pieces looked brilliant. No system seemed advanced. But together they formed a group that resisted, operated, and did what was expected, always. And that, for the engineers who had created the Tiger with its delicate engines and whimsical electronics, was a profound blow. The Reich didn't know it yet, but that American tank was just one of thousands. The Lima Locomotive Works, Chrysler, Ford, and General Motors plants produced vehicles with the same industrial efficiency as they produced tractors, buses, and locomotives. There was no technical secret. There was industrial maturity. In contrast, Germany, even with its brilliant engineers, produced tanks as if they were works of watchmaking. Each Panther was unique, each adjustment, a challenge, each repair, a matter of specialized workshop, and even so, they broke. The Sherman, by contrast, was built with generous margins, planned tolerances, and interchangeable components. It was a tank that accepted errors, imperfections, and wear and tear, and it kept running. The transport of War Daddy II to Kummersdorf was therefore not just a technical maneuver. It was the beginning of a discomfort that would spread through German engineering like a slow poison. Because there, in the test yard, surrounded by clipboards and skeptical looks, was proof that the enemy had prioritized what Germany despised: reliability. And in war, reliability was what really decided who got into combat and who got in the way. In the coming days, that tank would be subjected to a routine of tests that no German project had faced, not to confirm German superiority, but to understand what America had done so right, and why it threatened everything they believed about technical superiority. Because as they dismantled the Sherman, to study each gear, a truth began to emerge in the papers, in the spreadsheets, and in the eyes of the engineers. Maybe, just maybe, they had never built anything that really worked like that. And what would come next in the endurance tests and in the comparative analyses with the Panthers themselves would make this suspicion even more impossible to ignore. When German engineers began the complete disassembly of the Sherman in the Kummersdorf laboratory, the atmosphere was one of quiet expectation. They hoped to find the reflection of what they had always attributed to American engineering: cheap solutions, rough workmanship, industrial improvisations. What they found, however, was a project that contradicted their most basic convictions. The broadcast was the first surprise. He used herringbone-type helical gears, a choice that distributed stress more widely between the teeth, increasing durability and reducing noise. By German standards, those gears were too sophisticated to be produced at scale. But there they were, manufactured by the thousands, working with precision without relying on manual adjustments. The German technicians, accustomed to straight-cut gears that required constant maintenance and specialized operators, took notes in silence. They continued with the tests. Each axis seemed oversized. The clearances in the mechanical fittings were larger than the designers of the Panther would ever accept. But none of these imperfections compromised performance. On the contrary, this was what allowed the Sherman to tolerate sand, mud, thermal variations, and inexperienced operators without fail. The tank had not been made to impress in technical manuals. He had been made to keep walking, and that, little by little, was becoming impossible to ignore. The engineers disassembled the gearbox and discovered another shock: 5 gears forward, with synchronization between the second and fifth. This meant that an ordinary driver with basic training could drive the Sherman almost like an automobile. It was not necessary to master double-clutch techniques, nor constant throttle adjustments. The transmission absorbed the errors. The technicians compared it to the Panther tanks, which required specialized drivers and prolonged training to operate the gears safely. A mistake in the Panther could mean a gear break or a complete locking of the gearbox. In Sherman, these same errors would be ignored by the system. The tank was forgiving. He forgave human failures. This concept for German military engineering was a doctrinal affront. The Reich's philosophy was based on the assumption that the equipment would be operated by meticulously trained men, and therefore that the machine could demand excellence. Sherman reversed this reasoning. He started from the idea that war did not wait, that combat imposed chaos and that the machine needed to survive that chaos, even when the operator made a mistake. Initial reports used careful terms, but the subline was clear. One engineer wrote, "The simplicity of the design belies a remarkably efficient maintenance logic." Another noted, "It is possible to disassemble and reassemble the transmission with minimal tooling and without loss of alignment." For Kummersdorf's coaches, this was a veiled humiliation. After all, their own tanks needed to be returned to the factories for deeper interventions. The Tiger, for example, required the complete removal of the turret to replace certain gearbox components. The Sherman could be partially dismantled in the field, with minimal support, and then came the analysis of the structure. The Sherman's armor was not thick like that of the Panther or the Tiger, but the way the plates had been welded, at angles with simple overlaps and modular reinforcements, revealed a manufacturing pattern geared toward mass production without sacrificing strength. The Germans called it common sense engineering, a compliment that, among Reich engineers, sounded almost like intellectual capitulation. The electrical system, in turn, was standardized, with redundancy of power supply for critical systems. A secondary generator allowed the tower to rotate even with the engine turned off, a measure considered luxurious by German standards. But there, on the battlefield, it meant being able to keep firing even in the event of a failure of the main propellant. Each system analyzed revealed the same principle: practical efficiency over theoretical refinement. The Sherman did not depend on perfection. It worked despite the environment, the mistakes, and the war. And technically, this was a revolution. The direct comparison with the Panther was inevitable. Kummersdorf's engineers began to superimpose technical sheets. They found that the estimated lifespan of the Sherman's diesel engine was 3,000 kilometers, while the first Panthers did not exceed $700 to $1,000 km, even under careful maintenance. With each item, the astonishment grew. What was supposed to be a comparison between the refined and the rudimentary was becoming a confrontation between the functional and the brittle, and the functional won. In one of the internal reports, a technical officer noted, with a restrained but revealing tone, "If this vehicle were mass-produced with minimal variations and interchangeable parts, it would have a sustainable operational advantage superior to any national model currently in the field." The phrase was sent to the Ministry of Armaments with medium priority, but the impact was already being felt among engineers. Many in private admitted that they had never considered it possible to combine simplicity and efficiency in a military project of this scale. What they called robust engineering was actually the result of decades of American civilian industrial experience, something Germany had never possessed to an equivalent extent. And now, this absence was beginning to take a real toll on the battlefield. In the following days, practical tests with War Daddy 2 would begin, on obstacle courses, climbs, sudden braking, and simulations of real combat. They would be tests designed to break the machine, and what these tests would reveal about their resistance would definitively put the German doctrine of technical superiority against the wall. Because it wasn't enough to function on paper, it was necessary to function under pressure, and that's exactly what Sherman would do. On the freezing morning at Kummersdorf, War Daddy 2 was positioned at the start of the test track like any other armored vehicle. The Heereswaffenamt engineers prepared a complete battery of dynamic evaluations: climbs to 30 degrees, emergency braking in mud, sharp turns in loose gravel, and continuous travel for more than 8 hours with a full load. The goal was to expose the machine's breaking points. No equipment, they believed, could withstand without showing fatigue under this kind of pressure. But Sherman didn't just complete the tests. He ignored them. The clutch maintained consistency. The transmission did not generate excessive heating. The engine, even pushed to the limit, maintained stable rotation, without jerks or dangerous variations. The brakes, simplified and mechanically applied, worked without loss of efficiency. Cooling tests, designed to detect overheating under continuous load, recorded lower than expected temperatures. It was as if the tank was operating within the bank, even in the most extreme scenarios. In failure simulation situations, where the Panther or Tiger would require maintenance, the Sherman just kept going. One engineer wrote, "The vehicle does not react like ours. He resists, and after that, it continues." The VVSS-type suspension, which many thought was primitive, demonstrated surprising adaptation to mixed terrain. Even after repeated passes through segments with stones and ditches, There was no critical twisting in the chassis. The belts, held by simple pins, did not show misalignment. And then came the longest test, 200-kilometer continuous on a simulated battle course, with maneuvers and random stops. The tank completed the race with fuel consumption within the expected range and minimal wear on the traction systems. When dismantled again for inspection, there were no relevant fatigue marks. For German engineers, this was more than strange. It was worrisome. The enemy had built a tank that did not need to be respected. It just needed to work. And it worked. By this time, the Kummersdorf yard had ceased to be just a technical center. It had become the scene of a confrontation between doctrines. The German one, which demanded perfection in each system, and the American, who accepted imperfection as long as it was predictable, controlled, and reliable. The irony of this story is that the solution was before them. American engineering had learned from the civilian market. Interchangeable parts, system redundancy, error tolerance. It was a philosophy of durability, not technical glory. If you're enjoying unraveling these facts, show your support. Like and subscribe so we can bring you more in-depth content, because there is still a lot to reveal about what was ignored and paid for in blood. At the conclusion of the tests, a technical report was delivered to the armored section of the Ministry of Armaments. Among the data, one sentence summed up the growing discomfort. In 3 days of continuous operation, no critical component failed. In our tanks, this statistic is unattainable. The document was kept confidential, but one of his excerpts would be quoted months later by Albert Speer in a personal letter, with an implicit warning: if they can do it by the thousands, then we are already fighting against time, and not against tanks. And it was this veiled recognition coming from the top of the Nazi industrial chain that paved the way for a new stage of testing, the direct comparison between War Daddy 2 and the Panther, not in theory, but in the field, face to face, machine against machine, and that was what awaited them in the next cycle. The reports began to circulate in secrecy among the Wehrmacht's engineering offices, passing through the hands of technical division chiefs, armament analysts, and finally reaching Albert Speer's desk. The numbers, carefully organized in comparative tables, left no room for ideological interpretations. The Sherman had up to 60% less maintenance demand per kilometer driven than the Panther. Its transmission lasted on average 2,000 km longer, and the time needed to change the engine was up to 70% less than that of German tanks of the same weight. One of the most commented passages behind the scenes was signed by a veteran engineer from the Kassel factory. The Americans have mastered the art of reliability. There's no flaw in the design, there's intention. It was a phrase loaded with technical frustration, almost a heresy for a generation of engineers formed under the ideal of Germanic superiority. But the most uncomfortable data came from the logistic analysis. While each Panther required a support chain with a minimum of 2 technical support vehicles and a truck of spare parts, the Shermans operated with a minimal reserve and could be repaired by mechanics with basic training. This meant, in practical terms, that American tanks spent more time on the move and less time in workshops. The reports also highlighted the modularity of American construction: standardized gearboxes, interchangeable engines, harness-redundant electrical systems. This allowed, for example, a damaged engine to be replaced by another of different origin, Ford, Chrysler, GM, without the need for adjustment in the fitting. In Germany, each engine was developed for a specific chassis. A Panther could not receive a Tiger engine. A Tiger could not share parts with the Panzer IV. German technical doctrine had created a closed, specialized, and vulnerable system. Speer, reading the reports, understood the extent of the problem. War was no longer a battle of tanks but of industrial philosophies. He noted in margin, "We designed to impress. They designed it to last." For the first time, someone in the upper echelon verbalized, even if in silence, the collapse of a doctrine that had guided the engineering of the Reich for a decade. German tanks had been conceived as mobile showcases of national genius, but they could not withstand the reality of modern warfare. The most brutal comparison came in an internal document that placed 3 parameters side by side: average operational availability, average time between critical failures, and recovery rate in the field. Sherman won in all of them. A colonel in the armaments department wrote bluntly, "Our problem is no longer their tank, it's our concept of a tank." Technical truth was undermining the ideological foundations. The belief that refined ingenuity could win against mass production evaporated in the face of evidence. The Americans had accepted design compromises, smaller armor, standard armament, limited ergonomics, in the name of operational continuity. And this continuity, they now realized, was true superiority. The most disconcerting realization came at the end of a 19-page report, signed by a team from Kummersdorf. Even if we don't have the same level of production, we should at least adopt part of the philosophy. Our tanks do not tolerate real war. This excerpt was never officially cited, but it would circulate among engineers of the new generation in the post-war period. Internally, the Reich already knew. They lost not because of the lack of genius, but because of the absence of pragmatism. The war required tanks that made it to combat, not that impressed on paper. By this time, the captured American machine was no longer seen as a curiosity. It was an uncomfortable mirror, and the German response, silent but brutal, was coming. Because in the following days, the engineers would try something unexpected, to put the Sherman side by side with a Panther in practical tests. Not just measure, but compare, item by item, mile by mile. And there in the field, the German doctrine would have its final test. The decision that would shape the outcomes of armor warfare was not made on the battlefield, but in the factories. While Germany channeled its resources to develop technically superior machines, the United States War Department made a distinct bet, almost heretical in European eyes, to build tanks as if they were trucks. The American industrial philosophy, forged on the assembly lines of Ford, General Motors, and Chrysler, advocated a simple principle. If you can't train the operator, simplify the machine. Sherman was born from this logic. Each component is designed to be functional, replaceable, and inexpensive to produce. The project was not the result of an obsession with innovation, but of a strategic decision to escalate the fight. In the original documents of the Army Ordnance Department, the Sherman is described not as a tank of technical superiority, but as a reliable and multipliable mobile platform. This explained why, between 1942 and 1945, more than 49,000 units were produced in different variants, and yet almost all of them shared compatible parts. American assembly lines operated in 3 shifts, with civilian workers, many of them women, shaping steel as if they were building tractors. And in essence, that was it. The Sherman was an armored tractor, a tank that accepted dirt, human error, wear and tear and misuse, and kept working. German doctrine, on the other hand, sought technical excellence. The Panther, with its sloped armor and high-velocity gun, was an impressive piece of engineering, but it cost 3 times as much as a Sherman, took months to produce, and did not tolerate mistakes. The complexity of the gear system, the delicacy of the interdependent suspension, and the need for specialized tools for maintenance made each Panther a unique piece, and therefore fragile in scale. Each Maybach engine had to be tuned individually. Each repair required specialized technicians. A Panther could dominate an open field, but it rarely got there. The contrast went beyond the workshop. It was cultural. American engineering was shaped by civil demands. The tractor that had to operate for decades, the truck that crossed miles without service, the automobile that any mechanic could open and repair. This logic was imported to the battlefield. And when the German engineers dismantled the Sherman, they realized that they were not in front of a mechanical marvel. They were facing a mature industrial product. What impressed me most wasn't the gun or the engine. It was the design philosophy. The gearbox did not require fine adjustments. The electrical connectors were color-coded. Suspension brackets could be removed with simple tools. It was a machine made to be replicated, damaged, repaired, and returned to combat. The Panther, even under ideal conditions, failed after 100 or 150 kilometers of continuous operation. The Sherman crossed 2,000 kilometers with minimal maintenance. This difference was not accidental. It was structural. And as the war progressed, the American ability to sustain armored offensives became impossible to ignore. The American commander could miss the route. The driver could reduce badly. Supply could be delayed. Sherman could handle it, not Panther. This operational resilience transformed the battlefield into a favorable environment for the Americans, not because they had the best paper tank, but because their tank was always there. This logic of being present, of being able to place the tank at the right time, in the right place in sufficient numbers, was the essence of American mechanized doctrine, a doctrine that accepted tactical mediocrity as long as it was supported by strategic reliability. In the end, this was the real advantage. Not power per unit, but constancy per army. And the Germans knew. In a memorandum dated January 1944, a German technical officer concluded, "The Sherman represents a philosophy which is foreign to us. He does not win by superiority. He wins by permanence." This phrase, hidden between pages of logistical data, summed up the gulf between the two approaches. Because in the end, the war didn't reward the most refined tank, but the one that was ready, fueled, and on the move. And what the German engineers would witness in the following tests, directly comparing the maintenance between the models, would leave this unquestionable. On the battlefields of the Eastern Front and in the fighting in Normandy, reports began to converge on the same observation. German engineering was failing. While the Shermans continued to rotate even under fire, the Panthers often broke down before they even saw the enemy. The failures went beyond what was tolerable. The gearboxes had lockups in the first 150 kilometers. The final units, responsible for transmitting torque to the tracks, exploded under the weight of the hull itself, and the Maybach HL-230 engine, even with manual adjustments, could not withstand the heat of continuous operation. It was as if each Panther was fighting not only against the Allies, but against their own internal structure. The German operating manuals, written by the manufacturers themselves, warned drivers, avoid using third gear on long climbs, a warning that, in practice, rendered the vehicle's tactical capacity useless on uneven terrain. In contrast, the Sherman offered smooth gear changes, constant torque, and demanded less from the driver. The reports from the front said it all. While our tanks await repair, theirs keep advancing. And the greatest irony imposed itself when German soldiers began to requisition captured Shermans as operational vehicles. In various Wehrmacht and even Waffen-SS units, American tanks with crosses painted over the white star were used out of necessity, not by tactical choice but because they worked. A German armor commander in a campaign report in France wrote, "We would rather use captured enemy Shermans than our own Panthers. They don't break down, and supply is simpler." The technical scandal reached Speer, who tried to intervene with orders to review the Panther assembly processes, but it was too late. The doctrine was compromised. The MAN plant in Nuremberg recorded on average more than 30% of Panthers with factory defects, requiring adjustments before they were sent to the front, and the number of vehicles that were actually combat-ready never exceeded 60% of monthly production. By comparison, the United States didn't just produce more, it produced consistently. By 1944, American tank production exceeded 29,000 units, while Germany could barely deliver 6,000. If this number impresses you, write in the comments, "absolute power," because that's what it's all about. A power that doesn't come from isolated genius, but from scale, from predictability, from constancy. War doesn't reward the engineer who designs the most beautiful mechanical schematic. It rewards the tank that's still running after 10 ambushes. And the Panthers, though feared in theory, became symbols of the Reich's own technical illusion. On the field, the reputation collapsed. U.S. officials began reporting abandoned Panthers less than 200 kilometers into use, with leaking hydraulics and locked gearboxes. There were armored vehicles that never fired a shot. Meanwhile, the Shermans crossed villages, replaced parts, went back ahead, a tank that forgived, that he accepted the mistake, that he adapted, and that's why he won. Technical collapse was no longer an engineer's theory, it was an operational fact. And in the next stage of the trials at Kummersdorf, the Germans would do the unthinkable. They would put the two tanks side by side, not for combat, but for a mechanical challenge, one against the other, continuous operation, and scheduled wear. The comparison that German doctrine had avoided for years was about to happen, and the truth would no longer be possible to ignore. In June 1943, among the rigid columns of propaganda extolling victories on the Eastern Front and promises of new secret weapons, a discreet note appeared in the Völkischer Beobachter, the official newspaper of the Nazi Party. The title was measured, "Technical Analysis of Captured Enemy Vehicle," but the content revealed more than the regime would like to admit. Between the lines, the text described the M4 Sherman as robust and functional, highlighting its solid construction, with a clear focus on ease of operation and maintenance. It was the first time that the Reich press machine had acknowledged, however veiledly, that the Americans had reached a technical standard worthy of attention. The article praised, with an almost scientific tone, the gyroscopic stabilization of the cannon, technology that allowed the Sherman to fire on the move with a degree of accuracy never seen in German tanks. The press used neutral terms: ingenious solution, practical utility, simplified approach. But for those who read beyond words, the message was clear. That was not a criticism. It was a warning. The threat now had a name, weight, behavior, and could no longer be ridiculed. Behind the scenes, propaganda officials discussed the impact of the text. Some considered it too dangerous, others necessary. Germany was beginning to prepare its population for something the generals already knew. The enemy, once seen as technically inferior, had built something that the Reich could not match. And it was no secret among engineers. Internal Heereswaffenamt documents, obtained months earlier, already described the Sherman as the reference model for maintenance under combat. The publication of the article did not come by chance. It was preceded by discreet meetings between technicians, military editors, and representatives of the Ministry of Armaments. There was a quiet understanding that it would not be possible to sustain the narrative of Allied technical inferiority for much longer, not with the numbers in hand, because while the Panthers broke down and waited for repairs in rearward lines, the Shermans crossed Sicily. While the Tigers devoured spare parts in mud fields, the Shermans were given standardized field kits and back up and running in a matter of hours. The article also mentioned, with subtlety, the American modularity of manufacture. It was a roundabout way of admitting what was becoming apparent to everyone who analyzed the logistical data. The U.S. was winning not just with tanks, but with the concept behind them, a concept that transformed civilian production lines into arteries of war. And at that moment, even the most fanatical defenders of German doctrine began to yield to technical realism. An internal memorandum from Berlin, classified as restricted circulation, recorded the impact of the matter on the morale of the technical units. One colonel wrote it down by hand. "We can no longer sustain the myth of American fragility. The facts are overtaking us." And it was true, because Sherman, though underestimated in speeches, was being studied in secret, compared in silence, and, in some cases, even praised in a low voice. The publication in the Reich newspaper was the first public sign of a respect that already existed behind the scenes, a disguised but undeniable recognition. From then on, the words would change. Technical arrogance would give way to caution. And in the archives of propaganda, a new agenda would begin to be put together. How to prepare the German people to face an enemy that, contrary to what they said, knew exactly what it was doing. And in the industrial corridors of the Reich, the answer would try to come in the form of haste, improvisation, and promises of new weapons. But the damage had already been done, because at that moment, among the columns of the party's own newspaper, Germany admitted, albeit without saying so, that it had underestimated the enemy, and this mistake would be costly. The confession that would follow, made not to the press but recorded by a field engineer after a last comparative test, would put into words what the regime was trying to avoid. They did not win with genius. They won reliably. And this sentence, still confidential, would be the starting point of the most brutal revelation of the test program. In the last weeks of 1944, when the war was already taking an irrecoverable toll on the German military machine, reports began to emerge that challenged the entire narrative of technical superiority built by the Reich since the beginning of the conflict. Armored units of the Wehrmacht and Waffen-SS, faced with logistical collapse and the increasing failure rate of their own tanks, began to employ captured Shermans, not as trophies, but as combat platforms. The first cases arose on the outskirts of Nancy and Metz, where abandoned American tanks in good condition were painted with black crosses and put back into service, this time against the Allies themselves. But the most emblematic episode would occur weeks later, during Operation Nordwind. In January 1945, the 10th SS Panzer Division, one of the most prestigious of the regime, crossed the snowy villages of Alsace with a fully functional M4A3 Sherman, integrated into the maneuver group. Allied reports captured the information with incredulity, but the photos were unmistakable. The American tank, still with part of the white star visible under the black paint, was leading an SS formation. No modification, no adaptation, only fuel, and the will to keep fighting with what worked. The contrast was shocking. Panthers were being abandoned with 100 km of use. Tigers bogged down in terrain that the Sherman traversed with constant traction. And now the enemy was using, and preferring, the equipment that was supposed to symbolize Allied inferiority. Allied technicians, while inspecting Shermans abandoned by the Germans after counterattacks, found improvised German manuals, maintenance codes scrawled on the panels, and ammunition adapted for continuous use. It was as if, behind the ideology, the soldiers of the Reich were doing the only rational thing, using what worked. Because while German doctrine required that its tanks be operated by specialists and maintained in dedicated bases, the Sherman adapted to reality. He endured improvised hands. It ran on fuel of dubious quality. It was fixed with basic tools. And he continued. This silent phenomenon, the operational acceptance of the Sherman by the Germans themselves, would become a milestone in armor warfare, because it didn't involve advertising. It did not involve theory. It was pure pragmatism, and at bottom, it represented a tactical confession that the Reich had lost the war of trustworthiness. More than that, it revealed the moral collapse of German technical doctrine. The tank that was supposed to humiliate became an alternative. The tank that should be studied became a companion. A German engineer, in an unofficial letter sent to the family in Dresden, wrote after visiting the testing ground, "To see a captured Sherman led by an SS lieutenant was like seeing a Prussian officer carrying a Soviet carbine, an image that should never exist, but that is now repeating itself." Confidence in national engineering was shattered with every mile that the American tank advanced under enemy flag. And more than humiliation, there was resignation. One quartermaster officer recorded that supplies for Panther became so scarce that captured Allied armor came to be preferred by reconnaissance units. And this recognition, although silent, was devastating, because it showed that the real war, the war of mud, snow, failures, and improvisation, had been won by a logic of production, not by a concept of superiority. The tanks of the Reich demanded a perfect Germany. The Sherman worked within the collapse, and it is this difference that has begun to shape the ultimate perception of mechanical warfare. The enemy didn't just use our tanks, he preferred them. And on the day that the High Command received a report indicating that captured Shermans were being resupplied with priority in certain units, the internal narrative fell apart for good. In the next chapter, the technical files will reveal a secret study conducted by German military engineering itself, which would conclude something unthinkable. If Germany wanted to continue fighting, it would have to copy, or learn, from the American tank. Because not even ideology could hide what the data was already screaming. Between February and March 1944, at the Kummersdorf proving ground and in maintenance units scattered throughout occupied France, a new layer of discomfort began to form, not among the strategists, but among the German mechanics themselves. Professionals trained to handle high-precision machines, accustomed to the delicate maintenance of Panthers, Tigers, and Jagdpanzers, were now faced with an enemy tank that could be dismantled in hours, adjusted without special instruments, and rewired as if nothing had happened. When opening the compartments of the M4 Sherman, the first German technicians expected to find crude improvisations, poorly fitted parts, or hasty solutions. But they found the opposite. A constructive logic focused on efficiency. The Continental R975 engine, an adaptation of an aviation radial engine, had wide front access, well-organized fuel lines, and components secured with standardized bolts, a rarity in the German context, where even changing a carburetor required millimetric adjustments and specific tools. The technical silence spread like shock. A veteran Wehrmacht mechanic, after 3 days working with a captured Sherman, recorded in his diary, "It's not a tank. It is a militarized tractor. And it works like a watch without the need for a watchmaker." Servicing a Panther, by contrast, required removing the turret for engine replacement. Its suspension system was composed of internal torsion bars that, when they failed, completely paralyzed the vehicle. The Sherman, on the other hand, operated with external coil springs, accessible with a wrench and some patience. In the field, this meant an abysmal difference. A broken Panther had to be towed to a specialized base. If it survived the transport, a Sherman could be repaired on the side of a road. Most humiliating, for many, was to discover that American maintenance instructions were illustrated with simple diagrams and numbered legends. Each screw had clear function. Each step followed a pattern. It wasn't necessary to interpret. It was just to follow. It was the difference between a machine made for engineers and a machine made for factory workers. And this difference, in practice, defined who would be able to return to combat. A document from the Heeresinstandsetzungsdienst, the Wehrmacht's repair service, compared the average recovery times in the field. Sherman, 6 to 12 hours for engine change. Panther, 48 to 72 hours, with crane and full technical team. The disparity was shameful, and it began to erode the morale of the coaches. Because up to that point, German technical pride was based on the conviction that complexity was synonymous with superiority, that a refined machine, full of ingenious solutions, was by definition better than a simple one. But the war showed the opposite. The superiority was in functionality, and especially in continuity. A tank that operated with minimal support was more lethal than the most advanced of the armored vehicles that could not leave the base. American philosophy, which at first seemed primitive, proved devastatingly effective. The Sherman was less sensitive to failure, less demanding on lubrication, more heat-tolerant, and more stable in dirty, wet environments. The engine accepted low-octane fuel. The filters could be changed in minutes. Even the electrical cables were identified with colors. A German mechanic would write in a confidential report, something that would become almost legendary among technicians of the time. The American tank is stupid, but it's a donkey that never dies. This phrase, half mocking, half resigned, synthesized the ideological collapse from within. The technical elite of the Reich, trained in the engineering schools of Munich and Berlin, trained to venerate precision, were faced with a machine that operated by persistence, and that precisely for this reason dominated the battlefield. The breakdown of pride was not sudden. It was cumulative. With each engine that turned easily, with each clutch changed without disassembling half a chassis, with each reused part of another model without loss of performance, the German narrative of technical superiority gave up another centimeter. A 12th Panzer Division maintenance service commander wrote, after inspecting a $2,000 Sherman M4A3 in continuous use, "Our biggest mistake was to build tanks to be admired. They built tanks to be used." And this admission, still hidden in the technical archives, would be the prelude to the final confrontation between doctrines, because the engineers of the Reich were about to perform one last experiment, to place a Panther and a Sherman side by side, under identical conditions, not in combat, but in maintenance. Survival time would not be measured in shots, but in workshop hours. And in the result of this test, the last mask of German technical superiority would fall once and for all. In the frigid vastness of the Eastern Front, where tanks not only engaged enemies but fought daily battles against the terrain, the German doctrine of mechanical superiority found its field of execution and of failure. During the Battle of Kursk in July 1943, the 4th Panzer Division's reports recorded a statistic that would never make it into Reich newspapers. Only 16% of the Panthers were operational on the third day of fighting. Most had been abandoned due to misfires, leaks in hydraulic systems, and early overheating. No enemy front had fired on these tanks. They toppled over before reaching the crossfire. Logistical panic spread among the technical units as commanders tried to reorganize the battalions with what was left. It was a collapse that started inside the engine. In a single SS Das Reich convoy, during a 27-kilometer maneuver on a wet dirt road, 9 of the 14 Panthers broke down before reaching the point of attack. 4 of them had to be destroyed by the soldiers themselves in order not to fall into Soviet hands. The scene repeated itself in swamps, snowy roads, and icy valleys. Tanks stalled, engines drowned, turrets locked. A force that was supposed to crush the enemy, immobilized by the mud. Meanwhile, the Soviets received hundreds of Sherman M4A2 diesel-engined tanks under the Lend-Lease program, adapted for extreme cold and simplified for field maintenance. These tanks, considered inferior by German engineers, demonstrated greater resistance to ice, better performance in low-pull maneuvers, and a higher rate of readiness under sub-zero temperatures. And more importantly, they rotated. In a letter from a Soviet technician to the Central Command, after tests with armored vehicles received from the Americans, the verdict was straightforward. It is not beautiful, it's not complex, but it works. Always. A Panther, when operating at low temperature, required a ritual of preheating and cleaning filters. The Sherman, in contrast, was restarted in minutes and continued without the need for technical adjustments. This kind of detail, ignored in design rooms, decided entire battles in the mud of Smolensk. And at a certain point it became impossible to hide the truth from the soldiers themselves. During the winter of 1944, the 2nd SS Panzer Division reported losses from mechanical failure, in excess of losses from enemy action in at least 3 consecutive campaigns. It was the statistic of shame, because while the world's most advanced tanks froze under their own weight, the Americans' inferior tank cross destroyed villages, maneuvered on makeshift tracks, and even returned to be refueled. If you've come this far and this statistic surprised you, comment, "Logistics wins," because in the end it was not the caliber of the cannon that decided the banks of the Volga, it was the machine that did not stop. And within the Wehrmacht, this realization began to erode the foundations of the armored doctrine. It was no longer possible to promise that the Tiger would make it to the fight. It was no longer prudent to plan offensives with Panthers without at least 2 days of technical review. In parallel, the Allies delivered Shermans with attached toolkits, spare filters, and field manuals that could be understood by soldiers with a basic education. The Reich, on the other hand, needed engineers to change belts. It was a system built to fail on a large scale. The failure of every German tank wasn't just mechanical, it was strategic. With each Panther stopped, a flank opened. With each Tiger sunk in the mud, a division retreated. It was German engineering serving as an obstacle to Germany itself. By the end of 1944, the General Staff recorded a grim note. On some East Prussian fronts, fewer than 1 in 5 tanks were available for effective combat. Not for lack of ammunition, not for destruction, but by failure. And this truth, which until then had been hidden in the technical reports, was about to be confronted directly at the testing grounds. Because in the face of operational failure, the High Command demanded one last official comparison, not between doctrines, but between realities. At Kummersdorf laboratories, the engineers were given the order, Panther and Sherman, continuous running, timed maintenance, and final report. It was the last chance for German engineering to prove with facts that it was still worth more than American simplicity. What would come next would not be an arms clash, but the final verdict of the Bolt War. From the spring of 1944, Germany stopped fighting only armies. He began to struggle with the very impossibility of keeping his industry alive. Allied strategic bombings previously concentrated on tactical targets began to deliberately target the nerves of war production, factories, railway centers, refineries, and above all, the installations responsible for the engines and transmissions of the Reich heavy tanks. In August, Maybach's plants in Friedrichshafen, major producers of the HL-230 engines used in the Panthers and Tigers, were hit in 3 consecutive attacks. Production plummeted. Entire lines were buried under reinforced concrete. Hydraulic presses, calibration tools, and millimeter machining centers were lost forever, and there were no copies, nor contingency plans. Germany, which prided itself so much on technical excellence, had centralized its industrial capacity in a few hands. As engineers raced to adapt secondary lines, they discovered an uncomfortable truth. There were no other lines. The production of precision parts required an equally precise supply chain, and Germany, suffocated by the sea blockade and metal shortages, no longer had access to what it needed to sustain its own system. In the same month, bombings destroyed part of the facilities of ZF Friedrichshafen, manufacturer of the complex transmissions used in the Panthers. As a result, the technical chain was broken at 2 simultaneous points: traction and propulsion. A tank that required 500 unique parts to operate now relied on crumbling factories and dead employees. The Wehrmacht was forced to resort to remanufacturing, vehicle cannibalization, and improvised adaptations that only accelerated wear and tear. In a confidential report to the Ministry of Armaments, an engineer warned, "We are keeping tanks with parts that were designed to operate only once." By this time, the battlefield was no longer just the Western or Eastern Front. It was the assembly line, and there Germany was being defeated day by day. Meanwhile, on the other side of the Atlantic, the reality was the opposite. The United States had reached the apex of its industrial strength. More than 10 factories produced different variants of the Sherman simultaneously. Companies such as Chrysler, Ford, and American Locomotive operated with uninterrupted shifts, fueled by local raw materials, efficient rail logistics, and, above all, a doctrine of total standardization. The parts of a Sherman made in Detroit fit perfectly into one made in California. The engines were interchangeable. The towers could be adapted. Production lines were adjusted in days, not months. When the Nazis destroyed one American plant, if they could do it, 10 others kept flowing. American industry wasn't just vast, it was redundant, flexible, alive. In 1944, the United States produced, on average, 2,000 Shermans per month. Even under submarine attack, even with ships sinking in the Atlantic, the supply line did not stop. The American war effort was not improvised. It was a system, and the Sherman was his most symbolic product. More than a tank, he was the physical manifestation of a mature industrial civilization, simple enough to be manufactured by civilian workers, standardized enough to allow for in-field substitutions, resilient enough to face the Russian winter, the African heat, and the Normandy bombings. In Germany, tanks became relics. Broken parts were waiting for months to be replaced. Specialized workshops were bombed before they completed repairs. With each Panther destroyed, the Reich lost months of work and tons of steel that would not be replaced. The Allies, on the other hand, lost a Sherman in the morning and received another in the afternoon. It was a brutal asymmetry, and it was not based on superior technology. It was based on industrial philosophy. The Germans had built tanks as if they were jewels, the Americans as if they were combat tractors, and tractors win wars. An internal report of the German Ministry of Aviation, dated October 1944, admits that the inability to reproduce our own solutions on a national scale is today the greatest threat to the continuity of our armored forces. This sentence, written by engineers rather than generals, exposes the reality that propaganda could no longer hide. The Reich had been won by mass production, by logistics, for standardization, for simplicity. The bankruptcy of the Maybach and ZF plants was not just a technical problem. It was a paradigm collapse. Germany, which bet everything on extreme quality, had forgotten that a war is won not by the best tank, but by the tank that can be mass-produced, operated by ordinary soldiers and repaired in the field. And, perhaps cruelest of all, for the first time in modern history, elite engineering was defeated by engineering on purpose. Complexity was defeated by reliability, the spectacle through repetition. And at that moment, when the industrial ruins were still smoking under the Bavarian skies, the commanders knew what it meant. The war could no longer be won in the countryside, because in the countryside, what was now arriving, it was just what was left. In the next block, the captured engineers' diaries reveal the internal frustration with the American industrial machine, and the final admission: it was no longer possible to compete. What the German engineers hadn't understood, until they completely dismantled the Sherman, was that the secret wasn't in extreme precision, but in the clearance. While the Panther was designed to operate at the absolute limit of its structure, with minimal margins between weight, power, and cooling, the Sherman was built with an almost heretical concept by German standards: planned excess. The Sherman's traction gear could handle up to 20% more torque than the original engine generated. The center differential was oversized. The axles, although simple, were reinforced with margins that would allow for extended use, extra load, and even heavier future versions. The result was a machine that not only worked, but survived. In tests carried out in the United States with long-journey prototypes, Shermans with more than 2,500 km on the clock still maintained full functionality, transmission, and clutch, something unthinkable for the Panthers, which required a deep overhaul every 150 km of combat. It was the philosophy of evolutionary robustness, to design today with tolerance for tomorrow's problems. The Americans called this field engineering, making machines that could be upgraded, adapted, maintained with minimal effort. This explained why the same hull of the Sherman would serve dozens of variants. The M4A1, for example, would receive heavier turrets, 76mm guns, additional armor, more powerful engines, and improved electrical systems, without total structural redesign. The chassis could handle it. The transmission was supportive. The suspension, that simple but wide helical suspension, absorbed the new weights without fail. It was a base that grew, a body that accepted grafts, and most importantly, this had all been foreseen from the drawing board. While the Germans built tanks as if each one were an individual work of art, the Americans built as if they were assembling a line of trucks to cross the desert. The difference in mentality was brutal. On the Panther, each part was custom-made with exact fittings, tight tolerances, systems that did not admit error. Any change required redesign. Therefore, when they tried to adapt new turrets or more modern engines to the Panthers, They faced structural failures, balancing problems, and the need to recalibrate the entire traction system. The Sherman, on the contrary, looked like an organism with an energy reserve. It could receive British anti-tank guns, new turrets, high-powered radios, extra armor, and diesel engines without collapsing, because it had been made with technical fat, with margin, with what engineers called purposeful overdesign. This was not accidental. It was American philosophy. The same logic that made B-17 planes withstand dozens of shots without crashing, or Liberty ships be built in weeks without losing structural integrity. America didn't design for peak performance. It was designed for continuous use, and the result was the creation of a generation of military machines that not only won, but lasted. The Sherman, in its original version, could hold up to 30 tons, but later versions exceeded this weight without compromising performance. In Europe, Sherman's Firefly with British 17-pounder guns weighed more, generated more recoil, required more torque, and still worked. They didn't break. It was as if each component had been prepared for something bigger from the start, and that made all the difference. When a Panther needed adaptation, it was like trying to redesign a Swiss watch in the middle of the field. When the Sherman needed adaptation, it was enough to replace the part, or reuse it from another variant. The doctrine of modularity, interchangeability, and redundancy allowed the same tank to serve different armies, roles, and fronts. An M4A2 could serve in Africa, be redeployed to Italy, and then end up in the Soviet Union. And in all cases it worked. A Panther, it could barely be transferred from one front to another without the need for critical technical adjustments. German reports began to recognize this difference in a veiled way. A document dated December 1944, signed by Waffenamt engineers, points out, the American tank behaves like an elastic system, admits failures, accepts extra load, tolerates adaptations. Panther, on the other hand, is a closed system. Any change unbalances its whole. This observation was not just technical, she was philosophical, and it revealed the great flaw of the German doctrine, confusing complexity with superiority. On the field, the ability to absorb impact, adapt, and continue operating was more valuable than any theoretical refinement, and Sherman proved it every day, on all terrains, under all conditions. By this time, German engineers themselves had begun to study not only the American tank, but the system that produced it. They found that factories in Michigan and Ohio were producing thousands of engines with just 0.3% loss, that assembly lines in New Jersey tested each transmission before boarding, that each engine shipped had a technical buffer, minimum power guaranteed above specification. This meant that the Sherman received not only functional parts, but parts that were already above average even before use. It was the opposite of the Panther, which operated at the limit. A German tank, when it left the factory, already carried with it the weight of maximum precision. An American tank, as it left the factory, carried the breath of the leftover. This was what allowed Sherman to continue evolving without collapsing. And ironically, this evolution was not celebrated with propaganda. It was just implemented, silent, functional, and constant. In the next chapter, we'll look at how this built-in evolution philosophy led to the Sherman being adapted for missions that had never been anticipated, and how it continued to operate even when the designers themselves had given up on it. Because when a machine is born with ease, it never dies when the world changes. It just transforms. In the Kummersdorf underground, after months of meticulous testing, the final report was typed by 3 senior Waffenamt engineers. The title left no room for doubt. Bericht über das amerikanische M4 Fahrzeug, Report on the American M4 vehicle. The document, consisting of 47 pages, detailed not only technical measurements, but a silent deconstruction of German doctrine. The first section dealt with autonomy. The Sherman, even loaded with standard ammunition and fuel, had traveled 2,040 kilometers in simulated operational cycles without presenting structural failures or loss of performance. In comparison, Panthers tested under the same conditions required replacement of final units in less than 300 kilometers. The second section looked at the transmission. The Sherman's synchronized system allowed smooth shifting even at high revs. The clutch withstood continuous pressure without slipping. The gears, forged, not milled, demonstrated greater wear resistance over long cycles. In the third part came the hardest blow: maintenance and accessibility. Technicians noted that the Sherman's engine bay could be accessed by a single mechanic, without the need for special tools. The change of radiators, filters, clutch, and even the power unit could be done with just 2 men in less than 4 hours. On the Panther, the same tasks required a full crew, calibrated tooling, and often partial turret disassembly. But the stretch that circulated the most among the officers was not in the tables. It was a phrase, simple, direct, written on the last page. American vehicle design reflects industrial maturity. By German standards, this phrase was a surrender. Maturity was not just praise. It was recognition that there was a superior logic, and that it was working. The results of the report reached the Ministry of Armaments and, weeks later, were taken to the Führer himself. Hitler read the dossier in silence and, according to Albert Speer, refused to comment. Later, he ordered to intensify efforts in the development of the Maus supertank, a colossus weighing more than 180 tons, expensive, unfeasible, and totally out of touch with the industrial reality of the collapsing country. The decision was symptomatic. While engineers tried to understand why the Americans could do so much with so little, the German leadership doubled down on technical megalomania. But behind the scenes, the Wehrmacht had already understood. A tank that could be maintained with interchangeable parts, operated by ordinary soldiers and serviced in the field represented more than an efficient design. It represented the collapse of the German vision of technical warfare. In private meetings, generals admitted that they could no longer count on the production of armored vehicles on a large scale. A colonel of the Panzer Lehr division summed it up. The difference is not in the tank, it is in the country that builds it. This veiled recognition began to appear in internal documents. Technical instructions were issued ordering the prioritization of captured Shermans for support operations. Workshops were ordered not to destroy parts of Allied tanks but rather to stockpile and repurpose them. The hierarchy did not call it defeat, he called it pragmatism. But the soldiers knew what it was. The American tank, once treated with disdain, was now seen as a working model. And the most disturbing thing, the German technical evaluation process itself had proven this. The symbol of German war engineering, precision, had been defeated by an engineering that accepted failures but did not stop. An engineering that foresaw the reality of the field, not just the office plans. The irony of this story is that the solution was before them. Simple, robust, scalable. If you're enjoying unraveling these facts, show your support. Like and subscribe so we can bring you more in-depth content. Because understanding the past requires dismantling it piece by piece. And in this case, it was Germany itself that dismantled. Kummersdorf's report was archived, but copies circulated discreetly among technical centers, armored commanders, and even Krupp engineers. It was required reading, not for the content, but for what it represented. The confirmation that the war would not be won by the most impressive tank, but by the tank that was always ready. From that point on, German doctrine began to crumble from within. The next documents will bring more than data. They will bring the psychological impact of this finding. Because after reading Kummersdorf, the engineers themselves began to write in their diaries, and in these private, uncensored pages would emerge the final confession: we could not do what they did. On the muddy plains of Normandy in June 1944, the difference between theory and practice was crushed by chains of steel and dust. The U.S. 3rd Armored Battalion advanced about 30 kilometers a day, maneuvering under constant fire between destroyed villages and minefields. Its Sherman tanks, considered inferior on paper, demonstrated something that no German technical sheet had predicted: continuous presence. Each morning, the units were ready to go. Each night, they came back running under their own engines. Meanwhile, Panthers of the 12th SS Panzer Division remained static on many stretches of the front, not out of strategy, but out of necessity. Many could not be connected. Others did not complete 20 kilometers without overheating, locking gears, or leaking hydraulic fluid. It was the supremacy that did not reach the front line. In theory, the Panther's high-velocity 75mm cannon could destroy a Sherman at more than 1,800 meters. But the gun is useless without the tank, and the tank is useless without the path, and that's precisely where the Americans won. At St. Lo, logistical reports show that the U.S. Army kept more than 85% of its armored force operational for more than 20 consecutive days, a feat that not even the panzer divisions at their peak had achieved. The secret was in predictive maintenance, the use of interchangeable parts, and above all in the design philosophy itself. A Sherman could be repaired in the field in a few hours. A Panther needed a workshop and special transport. The difference was brutal. In Operation Cobra, the American advance dismantled 3 German divisions in less than 5 days, not because of superiority in armament, but because the tanks were always on the move. While the Panthers awaited repair, the Shermans flanked, and the force that moves overcomes the force that waits. In an internal analysis of the Wehrmacht, recovered after the war, an officer notes, "If American artillery is the hammer, tanks are the rail. They never stop coming." This observation was reinforced at the end of 1944, during the Ardennes offensive. The American 4th Armored Group was able to reposition its tanks in less than 36 hours, covering more than 150 kilometers under blizzard, ice, and mountainous terrain. Of the 148 Shermans mobilized, 142 reached their final destination in combat condition. In contrast, German reports indicate that only 58% of the Panthers assigned to the 2nd SS Panzer's counterattack were operational by the end of the first day, and many were abandoned not by enemy action, but by mechanical failures. The theory of technical superiority had collapsed under the weight of continuous practice. The tank that worked every day was superior to the tank that once impressed. One of the most symbolic moments of this operational abyss occurred during the liberation of Paris. As American armored columns crisscrossed the city with Shermans decorated with flags and flowers, German engineers who had been captured in the previous weeks were still trying to understand how this machine, simple, ordinary, pragmatic, had beaten the engineering they so revered. The answer was in the details: redundant systems, dual filters, wide tolerances, and a logistical cycle that allowed the American soldier to order a spare part and receive it within 48 hours. The Panther couldn't compete with that. Not even Tiger could, because it wasn't a battle of armor. It was a battle of continuity. And Sherman, in this arena, was invincible. What the Americans did was turn a war vehicle into a living cog in their operational doctrine. A tank that was more than a weapon. It was a platform for movement. The American doctrine of rapid warfare with steady advance and saturation by mobility was only possible because its vehicles sustained this pace. German doctrine, based on concentration of force and precision counterattacks, required armor that worked like scalpels. But when the scalpel breaks before touching the field, even a sledgehammer is more effective. In the end, Germany discovered that it was fighting a machine that didn't need to be better. It just needed to be there. And she always was. The final report of the 11th Panzer Division, dated February 1945, summarizes, "Our artillery is sporadic. Our vehicles fail. The enemy does not stop. Their strength is permanence." The phrase ran through the German command as an involuntary admission of defeat, not by destruction, but by exhaustion. And what sustained this stay was the tank that they had underestimated from day one. In the next chapter, we shall see how this silent victory, this superiority based on constancy, was recorded in the German archives themselves. Because the true impact of the Sherman is not just in what he destroyed, but in what he forced the enemy to acknowledge. The German technical renaissance began long before the first Leopard 1 touched the ground of a proving ground. It began in the uncomfortable silence of 1945, when engineers of the old Reich, men who had devoted years to precision calculations, millimeter gears, and shields that defied logic, were confronted with the raw truth recorded in their own Kummersdorf reports. There was, line by line, the evidence that Germany had lost the war not just on the battlefield, but at the heart of engineering. It was a moral, industrial, and philosophical defeat, and it was definitive. When West Germany began rebuilding its armed forces with the creation of the Bundeswehr in 1955, a new generation of engineers inherited metal boxes filled with documents, hastily written reports, measurements, photographs, and conclusions between bombings. In them, Sherman appeared not as an enemy, but as a teacher. American simplicity, once treated with disdain, turned out to be a language of efficiency that Germany would need to learn if it wanted to reinvent its military future. The first step was to abandon the cult of complexity. The philosophy that had guided the Panther and Tiger, the obsessive pursuit of mechanical perfection, was now seen as a trap. It had produced formidable but fragile machines, the maintenance of which required a country that no longer existed. The new Germany could not repeat this mistake. So the engineers immersed themselves in the principles that had made the Sherman so resilient: modularity, redundancy, maintainability, wide tolerances, and mass production capability. They understood that true superiority was not in the boldest project, but in the one that survived time, use, and improvisation. The minutes of the first technical commissions of the Bundeswehr show direct discussions about this. We cannot build another Panther. We need to build a vehicle that operates on any terrain, under any weather, with any crew, one officer noted in 1957. Sherman's lesson was clear. The tank that arrives beats the tank that promises. When the Leopard 1 project officially began in 1956, German engineers did not seek to replicate the grandeur of the past. They sought reliability. The Leopard 1 was born light, agile, easy to maintain, and designed to evolve. Its turret allowed for gun upgrades. Its engine could be replaced in the field. Their armor plates were modular. It was a balance between power and pragmatism, something that would have horrified the designers of 1943, but which now represented Germany's technical renaissance. For the first time, German engineering aligned itself with strategic reality. Mobility and continuity were more valuable than a single perfect shot. And ironically, this turnaround was only possible because Germany had thoroughly analyzed the tank it tried to ridicule. In interviews decades later, engineers involved in the development of the Leopard 1 openly admitted that Kummersdorf's tests were the philosophical turning point of German engineering. One declared, "We have learned from the enemy what we should have learned before the war. Reliability is superior to glory." The Sherman's legacy lived on not only in the reports that survived the collapse of the Reich, but in the steel of the new German vehicles. Every easy-to-remove panel, every replaceable module, every decision made in favor of quick maintenance, everything bore the shadow of that M4A1, captured in Tunisia. Germany was reborn at the exact point where it had fallen. Arrogance has been replaced by technical humility. Extreme complexity gave way to pragmatism. And in the process, the Germans created one of the most respected tanks of the Cold War, a vehicle that reflected not lost glory but wisdom gained. The Sherman unwittingly became the silent mentor of post-war German engineering. And it is precisely here that history reveals its greatest irony. The tank that the Germans underestimated ended up shaping the future of German tanks. In the next chapter, we will see how this philosophical transformation not only redefined German engineering, but revealed the true force that won World War II, the industrial ability to build not just machines, but entire systems that never stopped working. The machine that silenced a nation had no impenetrable armor, no revolutionary cannon. It did not arouse the same visual fear as a tiger, nor was it part of the triumphalist propaganda of the Reich, but it rotated, every day, in all climates, with any crew. And by the end of the war, that tank, the Sherman, wasn't just a machine. It was the mirror of an idea that the Germans were not ready to face, that excellence lies not in complexity, but in constancy. When the Kummersdorf reports were finally archived and the Wehrmacht documents opened up to the post-war period, more than technical data was discovered. The collapse of a collective belief was discovered. From engineering academies to tank battalions, thousands of Germans had been brought up with an almost religious conviction that German technical genius was unattainable, that their tanks could not fail, that his engineering was invincible. The Sherman proved otherwise, not with one shot but with 2,000 miles without fail. The engineers who dismantled War Daddy 2 weren't just beaten by well-placed bolts or wider gears. They were defeated by the humility of the project. A tank that admitted human error, that tolerated production variations, that prioritized ease of repair over structural elegance. A vehicle that was designed not to impress, but to survive. And in doing so, it humiliated an entire culture of technical arrogance. Some accounts from the time show silent but devastating reactions. A Wehrmacht lieutenant engineer wrote in his diary, after weeks of testing the M4A1, "Everything we have been taught about engineering is here, only simplified. It's like we made classical music for a battlefield that required blues." The metaphor was unintentional but perfect. War was not a stage for symphonies. It was a quagmire, a frozen track, an engine that had to start in the middle of the night. The Panther was a work of art. The Sherman was a tool, and that's why he won. The irony deepens when one realizes that the greatest American victory was not the Normandy landings, nor the advance in the Ardennes. It was the silence of admiration imposed on a generation of German engineers. Generations that grew up with names like Daimler, Maybach, and Porsche as a reference, were forced to recognize the industrial maturity of Detroit, Lima, Grand Blanc. The production line won the engineer's altar, and this victory was moral, because it wasn't just about tanks. It was about how a society chooses to project what it believes in. While the Reich invested in weapons to show greatness, the United States invested in tools to sustain the march. The difference was subtle but lethal. American culture accepted imperfection as long as production was constant. German culture demanded perfection even if the result was paralysis. And when the war demanded continuity, the American philosophy prevailed. There are records of German soldiers who preferred to be assigned to units with captured Sherman tanks, not for ideology, but for survival, because they knew they could fight today, tomorrow, the day after tomorrow, because they trusted the machine. And in the end, that's Sherman's deepest legacy. He was the confidence machine, not mass destruction, not aesthetic intimidation, but industrial confidence, of the certainty that something would work because it was done with purpose, with clarity, with commitment to the essential. When the rubble of Germany was reorganized in the 1950s, this philosophy was not forgotten. It was absorbed. Leopard 1, created more than a decade later, bears the signature of learning. But long before it, there were archives, memories, and silences that said the same thing. The American tank was the reminder that true strength is not in impressing, but in continuing. And perhaps the hardest lesson was this, because while the Germans sought to impress the world, the Americans built the capacity to sustain it. In the next and final chapter, we will see how this philosophy, this combination of pragmatism, industry, and humility, not only won the war, but left a permanent mark on everything that came after. Because sometimes, it is the simplest machine that carries the weight of the most complex truth. At the end of a war where ideologies collapsed and myths were crushed by facts, there remained a machine as a silent witness to what really won: industry, logistics, simplicity. The Sherman, dismissively dubbed a mass tank, traveled more fields, won more distances, and held out for more hours than any armored vehicle devised in Berlin. It was not designed for parades, but to last. It was not created to be worshipped, but to be fixed. And in the end, he was the one who stayed. War Daddy 2 is not just a vehicle, it is the materialization of a pragmatic doctrine, which has accepted to sacrifice the superfluous to guarantee the essential. The German collapse, more than military, was structural. Tanks broke down, factories were not replaceable, systems demanded excellence in a world where failure was inevitable. Meanwhile, on the other side of the Atlantic, synchronized production lines, standardized parts, and civilian technicians kept the wheels running. Superiority was not measured in caliber but in continuity. The war was not won in the field, but in the interval between battles, when an American tank turned its key and moved on, while the German had to be towed. And herein lies the universal lesson. Modern wars are not decided solely by courage or strategy, but by maintenance. Logistics determines the strategy. Reliability beats talent. Simplicity swallows genius. Behind each victory, there is an invisible chain of industrial, philosophical, and operational decisions that define who will resist to the end. While the Germans tried to achieve the impossible, the Americans built the unbeatable, not because it was extraordinary, but because it was consistent. And consistency in war is everything. Albert Speer, Reich Minister of Armaments, would write years later in his memoirs, "We were defeated by trucks, and by machines that just worked." This admission, coming from the man who organized German military production, encapsulates the devastating irony of this story. It was not raw power that won, but power that remained attached. If you value surveys like this, which rescue the facts behind the advertisement, leave the like and subscribe to the channel. This helps us to continue unearthing truths forgotten by official history. And now we want to know from you, what was the most shocking data you discovered in this video? Write in the comments. And don't forget to activate the bell so you don't miss the next devastating historical fact. Don't go away yet. Listen to the next true story that will appear on the screen. Always remember, logistics determines strategy. Watch the next video here on the channel with another incredible story.